Hey guys, welcome to this session. Our topic is static electricity, and today we'll be discussing about the combination of capacitors. In the past video, we discussed the concept of these capacitors. We said they are instruments that store the charge. Said that the ability of these instruments to store charge is what we call uh, then capacitance. So today let's see the combination of capacitance. Now capacitors can be combined in a series or in parallel so as to prevent overheating by being continuously overheated. So these combinations of in series or in parallel is made so as to prevent the overheating that can occur because of continuous uh, discharging leads to continuous overcharging. So it is there just to prevent overheating that it could lead to the damage of all these capacitors. Now let's see the capacitors in series. As you can see, that's just an illustration of capacitors in series. Now, when capacitors are in series, simply the charge distribution, that is Q, is equal to the all capacitors, but the potential difference, that is V, and the capacitance are different. Now, from there, we can get the general formula, that is the total potential difference, that is equals to the addition of the voltage that is across to each capacitor. Take it V1 plus V2 plus V3. Now, from there, to get that Q upon Ct equals to Q over C1 plus Q over C2 plus Q over C3, since the potential difference is equal to Q over C. So if you make if you make Q the subject, it means you are trying to remove Q. So if you remove Q from the equation, you remain with the 1 over C total equals to 1 over C1 plus C1 over C2 plus C1 over C3, whereby Ct just is the equivalent capacitance, that is the combined capacitance for the capacitors in series. Now let's see the capacitors in pi. As you can see in the illustration, that's how just the capacitors are arranged in pi. Now, when capacitors are in parallel, simply the potential difference, that is V, is equal to all the capacitors, but the charge distribution, that is Q, and the capacitance are different. So from there you can see the difference between the capacitors in a parallel and in a series. So generally, therefore, we'll be equal to Qt, that is equal to Q1 plus Q2 plus Q3. We saw that in a series it was V1 plus V2 plus V3. But here Q is the one which you add simply Q1 plus Q2 plus Q3. But we know that Q equals to CV. So if you substitute the value of Q, that is CV, C total V will be equal to C1V plus C2V plus C3V. So therefore, if we remove V from the equation, then C total will be equal to C1 plus C2 plus C3. So whereby Ct is just the equivalent capacitance, that is the combined capacitance for the capacitors in parallel. So I hope it's clear. We've simply seen the combination of capacitors and the arrangement simply in parallel and series. Thank you.